11.3 video notes talking about chords today. So I don't know how much you've had with chords in the past, probably not a whole lot. Normally we just talk about like circumference and area and things like that. So chords are probably a new ball game here. So let's jump right into the notes. Start off by a definition, and then we'll have a few theorems or properties, and then we'll bust into some example problems. So first thing, what is a chord? Well, basically a chord is a segment, it's a line segment, whose endpoints lie on the circle. Alright, so maybe I don't know, I put an endpoint right here, and I put another one right there. Maybe I'll put them further away than that. If I can get my eraser going here. Maybe we'll do something like from here to here. That'll show up a little bit better. Then I connect them with a straight line. So that right there is what we're calling a chord. So I almost think of it as like a wannabe diameter. So it goes from like the edge to the other edge, but it doesn't go through the center. So the diameter is actually a special chord that happens to go through a center point. So now some theorems about this. If I were to go ahead and draw a center on here, kind of eyeball it, and if I were to connect this with an angle, all right, so there's a central angle right there, and it has that blue chord. Well, those three are all kind of related, and if I try to get that same angle somewhere else, so let me use my protractor here, and I'm going to try to copy this angle on a different part of the circle. So that angle is about 80 degrees. So let me just kind of get another one going, maybe right here, and then I'll measure 80 degrees. Come over here to 100 and come down this way. So here's another angle that's the same degrees. So this is 80 degrees, and I drew another one on here that's 80 degrees, and there's something kind of interesting over here. So when I look at the theorems, if two angles are central angles are congruent, so congruent central angles, this one equals this one, then they must have congruent chords. So basically, if I were to connect this chord right here, this and this are going to be equal to each other. So if you have the same angle starting out from the center and you go to the edge of the circle, the chord that you create are going to be equal to each other, or congruent in length. Congruent chords also have congruent arcs. So maybe I'll put this in red. So also this measure right here should be equal to this measure out here. Now we already knew that because we knew that the arc measure is 80 degrees for both of these because it's the same as the central angle. But the length is also the same, the measure and the length. And then finally, congruent arcs have congruent chords and angles. So just kind of going backwards. Chords and angles. So the idea is, if you have any one of the three, if you have information about the central angle, if you have information about the chord, or if you have information about the arc on the outside, if any of those are equal to something on the other side, all three of them are as well. So it's kind of a package deal. Central angles to chords to arcs. Alright, let's jump down and let's do some actual problems. I think it'll make a little more sense to us. So for number one here, it says QR, segment QR is congruent to ST. So this is basically right here that says this guy is equal length to that guy. So because of that reason, I know that arc, minor arc ST, alright, so the measure of arc ST is going to be equal to the measure of R to Q, the measure of arc RQ. and because of the theorem up above, since the chords were equal, the arcs have to be equal. And now I just kind of substitute the values in. And so this was 4x, this was 3x plus 22. I do a little bit of algebra, and I find out that x is 22. Now I'm not quite done yet because they actually want me to find out how long QR really is. So since QR or RQ is 3x plus 22, I need to take this number, I need to plug it in right there. So 3 times 22 plus 22 should be 66 plus 22, should come out to be 88 is the measure of QR or RQ. I could write it kind of however I want. So just a little bit of algebra there. All right, moving on to the second one. So looking at the diagram, I'm given that these two central angles right here are equal. Let's just call them angle 1 and angle 2. So given that angle 1 is equal to angle 2, it's a weird looking 2, I know that both the chords and the arcs are equal. So I know that the HG is congruent. So HG is congruent to JK. And then I don't really need it, but I also know that the measure of arc HG is also equal to the measure of arc JK. That doesn't come up in this problem, but we're actually concerned about the chords. So let's do this. HG is 2y plus 5, and JK is y plus 13. And I do my algebra. I subtract the y's from both sides, and then I subtract the 5 from both sides, and I get y equals 8. Now they want me to find the length of GH. So I'm going to plug that 8 back in right here. And 2 times 8 is 16 plus 5 gives me 21 is the length of GH. Segment GH has a length of 21. Alright, next page. So nothing too heavy so far, just mainly some algebra. So now we have a theorem, another theorem, and this is probably tested more often than the other one, so I'm going to star this. It's a little more important. But if a radius is perpendicular to a chord, so let's kind of do this. I'm going to just draw some chord, and if the radius is perpendicular to it, so let's go from the center. And I'm going to try to draw a piece that's perpendicular here, and kind of using a piece of paper for a good straight edge. So I think what I've drawn is I've made sure that the radius is perpendicular to the chord. So if that happens, if you see that happens, what we can say is then it bisects the chord. And this is tested quite often, so make sure, and remember bisect means cut in half, cut in 2 equal pieces. So since I see that radius is at 90 degrees, I know that this piece has to equal that piece. That's what I can say. Now this is going to open up the door for some Pythagorean theorem problems later on, because anytime you have a right angle in there and you can make some triangles, Pythagorean theorem kind of comes into play. So let's do a few of these at the bottom to finish things up. So number 3, we need to find x on this problem. The directions don't really say that, but I'm going to just write it in right now. Find the value of x. So we need to find this piece right here. Alright, well the first thing I see is this line right here, this blue line right here, is perpendicular to a chord. Alright, so here's my chord. And since the radius is perpendicular to the chord, so since the radius is perpendicular to the chord, it bisects it. So I know that this piece equals this piece. So that kind of helps me, because trying to find x, it looks like if I focus my efforts on this triangle right here, the red, blue, and green triangle, if I kind of focus my efforts right there, I think I'm going to be able to use Pythagorean theorem. Now, why the formula come into play is because since this top line right here is 8.3, that means this line right here is 8.3. All right, so that's where this little part right here gave me. It gave me that those two are equal. The 3.9 is really unnecessary. The 3.9 describes this little piece, and I don't even really need that on this problem. Now, in order to do Pythagorean theorem, I need 2 out of 3 sides. I have one side here. I'm missing this side. That's what I'm after. But I think I can get the green side here. I think that we can find this length because the diameter is 21.8. So if I divide that by 2, that'll give me, what's that, 10.5, 10.9? So I believe this piece over here is actually 10.9 because it's a radius. It's half of that. So now there's a couple ways I could do this. If I wanted to not have to do the Pythagorean theorem, you know, something I kind of just noticing right now. So right now you could go one of two ways. If you really want to work hard, I could say x squared plus 8.3 squared equals 10.9 squared, and I could solve for that. But if you want to go the little bit easier route, maybe I shouldn't have erased that 3.9, okay? Because I noticed that right here, this green line, that's a radius, and the radius is 10.9. So that means that this entire blue line, okay, also has to come out to be 10.9. So I think if I do my math, x has to equal 7, because then you'll have 7 plus 3.9, and it'll come out to be 10.9. So I'm going to use the radius to give you the answer. That the answer is 7. So that one wasn't too bad. But you could have went the Pythagorean theorem out if you wanted to. That's the way I was going to do it in the first place, but that would have been kind of overkill. Alright, so the next one, let's see what we got. Looks like I have all my pieces set up. That's the piece I need. I have 8.3, and I also have the hypotenuse, which is 10.5. So I think I can just start off, get my equation going here. Legs squared plus legs squared equals hypotenuse squared. Notice the 10.5 was down here in the middle, so I knew it was the radius. Where on the problem before, it was up here in the middle, so I knew it was the diameter. But if you're unsure, just ask me in class if you're working on a problem or on a quiz. So x squared plus 68.89 equals 110.25, and I'm going to subtract that 68.9 from both sides, and I will get 41.36, and then we take the square root, and x is about 6.43 when you round it. So you can go 1 or 2 decimal places, not that big a deal for me. Looking over here at number 5, so actually the x, or the piece that I want, is right here, and I do see that this radius right there is perpendicular, so that tells me that this side, which is 13.4, must equal this side, so I can write in my own 13.4. And I need to find x. So let's see what we can kind of do here. Oh, this one's a little bit tricky. So I'm going to erase that 13.4. It's true, but I'm going to kind of do something like this. This one's going to require a little bit of work. Why did they give me that this is 15, I wonder? You know, that's going to come into play at some point. And I'm going to draw my own radius in on this one. So this is pretty important. you need to draw your own radius to kind of help you out. And I'm going to draw it right there. I drew my own radius in. Now, all radiuses are equal, so I know that black radius is 15. I know that the red was 13.4. And in order for me to get x, I'm going to first find y. I'm going to call this little piece right here y. And I'm going to find y. Once I find y, I'll be able to find x because x plus y is just equal to the radius. So let's kind of get after this one. So let's do leg squared plus leg squared equals hypotenuse squared. So I do some work there. And I get y squared plus 179.56 equals 225. Minus the 179 from both sides. So it looks like I'm going to get, what's that, 45.44. And now we take the square root, and I get y equals 6.74. Now that's not the answer, okay? It's not the answer just yet. This right here is 6.74. So here's kind of how you close the deal. I need to figure out how long x is. And I know this whole green line right here is a radius. All right, that line right there, if the radius, so basically x plus 6.7 equals 15, okay, because it's a radius. And so I just minus 6.7 to both sides, and I get x equals 8.3. That was a tough problem. There was a lot going on that one. So first thing you have to do is find y, then you got to go back in, you got to find x. I like that problem. That's a multi-step problem. Separates the men from the boys, so to speak. So that one's tough. Always know, though, that you can draw in your own radius if it helps you. Alright, last one, number 5. This is just kind of a little method to how you can find the exact center of a circle. So if you're given a circle and they're like, hey, where's the center point at? Something you can do is basically a couple steps. Number one is draw 2 random chords. So let's just make, I don't know, I'll throw one down here, and then I'll make maybe a bigger one up there. All right. So I have two random chords drawn in. So that's step 1. Number 2 is going to be draw a perpendicular bisector for each chord. So perpendicular bisector, basically I got to do 2 things. I got to find the midpoint at 90 degrees. So I'm going to measure this using a big ruler here. So this top blue chord looks like it's 21 inches on my board. So that would be about 10.5. So there is the center. And then I find the middle of the other one, which is 13 inches, so that would be about 6.5. So there's the center. So I've done the midpoint part. Now I have to do the 90-degree part. Now I have to go ahead and hit that at 90 degrees. So you could use a protractor. I'm just going to use a sheet of paper. So I'm going to line up a sheet of paper on here and get my 90-degree angle. And it goes to about here. So I'm going to connect those dots. So now I have a line that is 90 degrees. And then I'm going to repeat the process for the top line. Get myself a dot off of 90 degrees. Again, you can use your protractor, you can use paper. And I'm going to connect these two. and that's 90 degrees. And now that magic spot where they cross each other, right there, is the exact center of the circle. So step 3 would be the intersection of the perpendicular bisectors is the center. All right, so not too bad. Closing in on almost 20 minutes, so not too long a video, but hopefully that gets you what you need so that we can battle through the practice tomorrow. See you.